Hi, and welcome back to the seventh section of this course about successful applications of deep learning. This section will be divided in 5 small videos. In the first one, we will talk about the impact of deep learning in the context of computer vision, and we will cover very rapidly the main applications for which a neural network approach has reached the new state of the art. Then we will move to the field of natural language processing and audio signal processing and do the same in the second and third videos. After that, we will learn more about the possibility of solving more complex and multimodal tasks, that is, tasks for which we need to use more than one perception modality, like vision and language understanding together. Finally, in the last video, we will cover some of the many other very successful deep learning applications in other fields you may be interested in, like healthcare or finance. So let's move to the first video of this section, deep learning for computer vision. In this video, we will firstly understand the impact deep learning historically had on computer vision. Then, as we have said, we will introduce some of the many successful deep learning applications in computer vision, and finally going a little deeper into details, focusing on dense object detection, which with all the knowledge you have acquired so far in this course, with just a little bit of effort, you'll be able to understand and apply to your own problem. So let's start. The field of computer vision is one of the first fields which has been profoundly changed after the reborn of neural networks through deep learning. It was in October 2012 when Hinton and one of its students, Krzyzewski, won the large-scale object recognition challenge ImageNet by a significant margin over other shallow machine learning methods. Since then, CNNs and deep neural nets have been commonly adopted in computer vision for many tasks, and the current list of state-of-the-art deep learning applications in this field is becoming somehow impressive. One of the most successful applications which comes in mind when talking about deep learning and computer vision is, of course, object recognition. Object recognition is the application we have seen in the section of convolutional neural networks, where we would like to predict the object contained inside the image. Another interesting task is object detection, for which we don't have only to recognize the object, but also to detect the position of such object inside the image. As you may imagine, convolutional neural networks are still the right way to go, and we will see how in the next slide. Another very interesting application of deep learning to computer vision is the ability of recognizing actions in videos. So, for example, in this image on the right, you can see an application from the Facebook AI team where the model was able to recognize this funny sport, mountain unicycling, among many other more common sports like soccer, basketball, and so on and so forth. Realistic image generation is another hot topic at the moment in the computer vision and deep learning community, since it involves new methods, which seems the right way to go for tackling unsupervised learning. And we are now able to generate nearly realistic images without any label. But don't worry, we will talk more about this in the last section of this course. Finally, I would like to mention another fun application, which is coloring black and white images. And it turns out that a deep neural network can be pretty good at that. And in the end, this is reasonable since we have an unlimited number of training examples, just downloading from the web a large number of RGB images and converting them to grayscale. So even if these are just a few examples of all the successful applications of deep learning to computer vision, you can now understand why deep learning can be so valuable for a huge number of commercial applications. Now, let us focus on a single case study like dense object detection. So, dense object detection is one of the most interesting and useful applications you may want to implement and apply to your own problems. In this task, we would like to simultaneously detect many objects inside the image and possibly of multiple classes like in this image below. How would you approach this problem with all the things you have learned so far? The simplest approach would be to just train a CNN in the pipeline described in the image below, for what is called a region CNN, where we take an image as input, we extract the region proposals with a specific and external algorithm, then we stretch them to fit the CNN input size, and we run them through the network. Once we have done that, we can extract the last before hidden layer and classify that low-dimensional representation with an SVM module, for example. But we can still improve our naive solution in two ways. First of all, we can avoid to convolve each time every region we choose in the image and just convolve the image a single time, choosing then the region of interest directly on the last feature maps before the fully connected layers. And secondly, we can substitute the external SVM module with a multiple objective function for output direct class and the adjustments for the bounding box around the object of interest. Even more efficient solutions are available, and I suggest you to check the last model called Faster RCNN for further details.